Yeah.
Did I do it?
Yeah.
You have a video of me explaining this?
Yeah.
Oh. Okay.
I think it's better if you just do it again because like
Okay,
it
are
was
you
not
rolling?
good quality.
Okay, this is number 58 on page 378 in Giancoli. It's the baby heart question. So the baby's heart is beating. We send in an ultrasound. The frequency is 2.25 times 10 to the 6. That's the frequency of the sound. And we know the speed of the sound. It's a little faster than normal. I think it's 1.5 times 10 to the 3, something like that. But it's written in the question. As the sonar comes into the heart wall is moving away. And so we have to use this equation. This is in your data booklet, but you have to know that it's minus. Because in the IB data booklet, they put a plus and a minus, so you have to know that moving away is a minus. And then when it bounces back, the heart wall becomes the source of the sound. But it's still moving away. So the source is now moving away, and that's this equation. This is the velocity of the observer, this is the velocity of the source. In this case, it's the same thing because the heart wall has some velocity, and so these two things are the same. These are the velocities of the sound. This is the original frequency. That frequency changes when the heart is observing it, so that becomes F1. And when you do the second equation, the original frequency is F1 because it's absorbed the wall, the sound, and now it's pushing it back. So we take all of this and we plug it in for F1 over here. And then we do a little bit of math, we cancel those things. You end up with this, V minus U over V plus U. And notice we just said U because the heart wall's velocity is the same. And then we say, we know that the second frequency, the beat frequency in the question is 600 hertz. This is very confusing. The wording is confusing. What that means is that the original frequency has changed. It's dropped by 600 hertz. So that's what the machine would read for you. So what that means is that the second frequency, the one you get back out of the baby, is the original frequency minus 600. So if we put that all in here, and we do this, we took the V plus U and put it up here. This one stays. And then you expand it all out, you collect like terms, you got your U's over here and your V's over here. You factor out the U and put this F2 plus F down here, and the V factors out over here. And then you get U with respect to all the stuff you know, and then you just plug it in. You plug in F minus 600 for F2, and if you figure this out, you should get 0.205, was it? That's the answer.